Good morning. My name is Daria Orlowska. I'm the data librarian at Waldo, and today's session is managing your data in spreadsheets. So the goals of this workshop are to set up a spreadsheet for good organization, recognize common formatting mistakes, and learning to employ basic quality control. So hopefully by the end of the workshop, you'll be able to do all of these things. You may be thinking, why is this important? Aren't these goals something that most of us already know how to do? I would argue that while this workshop is straightforward, it contains skills that are often not touched on in classes. So managing your data is a kindness to your future self and to others. And time spent doing it well will allow for less guesswork and more effective data wrangling. So how many of you have used some sort of spreadsheet software, either for class, for work, or for your personal use? You can feel free to use the chat or raise your hand. Great. And how many of you have had something go wrong in a spreadsheet that has made you frustrated or sad? Anyone had that experience in the past? Yeah. Yeah, if anyone wants to share, if you're feeling confident, would like to unmute yourself and share your experience or write about it in the chat, feel free. If you do not want to, I will share an experience. So when I took my first full-time job as a research assistant and found spreadsheets weren't being set up well, we weren't capturing the information we should have been, and information that we were capturing was sometimes incorrect. It was frustrating to never have the right data on hand when collaborators asked for an updated data set. No one had ever set up any guidelines for managing data well, so it was left to individual research assistants to figure it out, which created inconsistencies. One time, a research assistant accidentally autofilled the same value for a part of a column, and the mistake wasn't noticed until months later when the supervisor asked for a report. So even though Excel had some versioning by that time, it was 3 months later and all the versioning had been overwritten, and we had to go in and manually put in the information that we were capturing in paper files in order to correct that autofill error. So yeah, data management, very important. So what are some common uses for spreadsheets? Spreadsheets have a lot of different functionalities. What do you use them for primarily? Do you use them for data entry? Do you use them for analyses? How are you using your spreadsheets? Feel free to type things into chat. Stats and data entry, yeah. I think that's pretty common. Plotting, yep. So while spreadsheets are good for data entry, it's important to exhibit caution while using spreadsheets to create figures or statistics. Not because it's not a good use of them, but because it may be difficult or impossible to replicate your steps. So if that's something you care about, it's important to keep that in mind. It is also very easy to apply a slightly different formula to multiple cells, which can throw off your results. It's best to use statistical programs like SAS or R to do these functions because you have better documentations for the steps you took to get a result. However, spreadsheets are great tools for organizing, cleaning your data before importing them into a statistical program or using them for quick calculations. For the rest of this workshop, we will be discussing these two uses through examples to identify practices that you can apply to managing your own data in spreadsheets. Okay, formatting data tables. I will preface that although all of these examples are within Excel, for this first part of the presentation, you actually don't need to be using Excel. It's just being used as a vehicle to showcase the data and the different types of formatting, and not You don't need any knowledge about using the program in order to make use of these examples. So here is an example of data from a research study deposited into Figshare, which is a multidisciplinary data repository. What do you see here? What are some things that jump out at you? Multiple tables, yeah. What else? Is anything confusing? How are titles being treated? Some missing data? Date formats, yeah. Sometimes it's not clear how things are formatted. Yep. So the most common mistakes we can make with spreadsheets is treating them like lab notebooks, relying on context, layout, and external information to convey information. So this works for humans most of the time, but a computer will not understand how this information fits together. This can limit your ability to work with the data in other programs, or even allow your colleagues or future selves to understand the data 6 months from now. This is why it's so important to set up our data in a way that is well formatted from the beginning before data entry even begins. So we will come back to this example. So let's go over some common formatting problems so that we can get the lay of the land. Using multiple tables. A common problem is creating multiple data tables within one spreadsheet. When you create multiple tables within one spreadsheet, you're drawing false associations between things for the computer, which sees each row as an observation. You're also potentially using the same field name in multiple places, which makes it easier to clean your data up in a usable format. In this example, the computer will see row 4 and assume that all columns A through F refer to the same sample. This row actually represents 4 different samples, so one sample for each of the 4 collection dates, as well as some calculated statistics, an average and a standard error of measurement for 2 of those samples. Other rows are similarly problematic. Okay, let's look at a different example. Using multiple tabs. So what about workbook tabs? This seems like an easy way to organize data. But when you create extra tabs, you fail to allow the computer to see connections and data that are there. Say, for instance, you make a separate tab for each day or month you take a measurement. This isn't a good practice for 2 reasons. One, you are more likely to accidentally add inconsistencies to your data if each time you take a measurement, you start recording data in a new tab. And 2, even if you manage to prevent all inconsistencies from creeping in, you'll add an extra step for yourself because before you analyze the data, you'll have to combine all this data into a single table. You will have to explicitly tell the computer how to combine tabs, and if the tabs are inconsistently formatted, you might have to do it manually. So the next time you're entering data and you go to create another tab or table, ask yourself if you could avoid adding this tab by adding another column to your original spreadsheet. Your data sheet might get very long over the course of the experiment, which might make it harder to see things at the very top, but remember that you can go ahead and freeze columns and headers so that they remain visible even when you have multiple rows within your spreadsheet. Missing zeros and problematic nulls. So it might be that when you're measuring something, it's usually a 0, say the number of times you did an action or observed a thing. But why bother writing in the number 0 in the column when it's mostly 0? However, there's a difference between a 0 and a blank cell in a spreadsheet. To a computer, a 0 is actually data. You measured it or counted it. A blank cell means that it wasn't measured, and the computer will interpret it as an unknown value, otherwise known as a null value. The spreadsheet or statistical program will likely misinterpret blank cells that you intend to be zeros. By not entering the value of your observation, you are telling your computer to represent that data as unknown or missing. This can cause problems with subsequent calculations or analyses. For example, the average of a set of number which includes a single null value is always null because the computer can't guess the value of the missing observations. Because of this, it's very important to record zeros as zeros and truly missing data as nulls. I'd also like to draw your attention to this table about commonly used null values. There are many best practices depending on the field you're in about what you fill in when you don't have any values. Certain fields, notably psychology, there was a practice where you would fill in 999 if something was null. However, you should keep in mind that if you will have null values that you're labeling a specific way, that those values don't make it into your analyses because they can really throw off your statistics. There are some best recommendations on what you should be using for each program. A lot of the times, a good option is to put none or null within it, but you do want to keep those, the way that you're using nulls within your spreadsheet, you want to keep those in mind so that when you're doing calculations or when you're transforming data, you can take them into account. Formatting and comments to convey information. So highlighted cells, rows or columns that should be excluded from analysis are currently highlighted, leaving blank rows to indicate separations in data. So in this example, someone has highlighted rows that they think that are possibly misidentified. And in addition, they have highlighted columns to show that the measurement device was not calibrated. How can we transform this data set to make it better so that we don't have colors to indicate information? Any suggestions? Create another column. Yeah, that's probably the easiest way to go about it. Because right now, you are relying, in this case, on Excel to preserve your spreadsheet in exactly the manner that you're saving it as. However, when we talk about it later, when you're transforming your file into something that is more widely reusable, like a CSV, you actually lose all formatting. So any cut and colors that you're applying to the rows will be will not exist anymore once you convert it, or even if you transfer it into a different program. So you really don't want to rely on colors when you're sharing your data. And you do want to create a new column to convey that information. Okay. Problematic variable names and special characters. So choosing descriptive field names is very important for your data set because it gives you information and you know exactly what you need to be entering for each column. But it's important to not include things like spaces or special characters of any kind, or even sometimes column names that start with numbers. So spaces can be misinterpreted by parsers as white as delimiters, and some programs don't like field names that are text strings that start with numbers. Underscores are a good alternative to spaces, and it's also useful to write things in camel case. For example, you capitalize the first letter of a phrase, and then you don't add a space. Instead, you capitalize the second letter of the next word to improve readability. Remember that abbreviations that make sense at the moment may not be so obvious in 6 months, but don't overdo it with names that are excessively long. Including the new units in the field name avoids confusion and enables others to readily interpret your fields. However, you should be careful that when you are putting units, such as in the first example, degrees Celsius, that you are putting it in a way that is not introducing special characters like parentheses or the degree symbol. Metadata in spreadsheets. This is something that I'm sure a lot of people have done. You add a legend to the top or bottom of your data table explaining column, meaning, units, exceptions, and so on. Why is this a bad idea? Any guesses? So like we had in the previous example, used colors to denote extra information. This is also a form of extra information. It is something that when the computer looks at it, it will treat the entire row as one source of information. So if you're looking at row 5, it's going to continue looking at location column 1 and having that information in there as well. It is, you're right, it is also tedious in the sense that if you have to go and you're sharing that information with someone else, you have to make sure you're removing that legend. So recording data about your data, metadata, is essential. You may be on very intimate terms with your data set while you're collecting and analyzing it, but the chances that you will still remember what the variable, which is an abbreviation and then another abbreviation means, or the exact algorithm you use to transform a variable or create a derived one after a few months or after a few years is kind of slim. There are many reasons other people may want to examine or use your data to understand your findings, to verify your findings, to replicate your publication, to replicate your results, or to design a similar study. But while the digital data is readable by humans, such as you and I, it is not very machine readable. So it is important to document your data during the collection and analysis, but it shouldn't be contained in the data file itself. So unlike a table in a paper or a supplemental file, metadata should be included in an extra file. So for example, a text file that is stored in the same directory as your data file, preferably in a plain text format, with a name that clearly associates it with your data file. Because metadata files are free text format, they allow you to encode comments, units, information about how null values are encoded that are important to whoever is looking at your data set. A folder level README text file is a classic way of accounting for all the files and folders in a project. Entering more than one unit of information. What stands out to you in this spreadsheet? What is something that can be improved upon? Column E, count, yeah. So you have something that says SM, 6M to F for the second row, presumably meaning, in this case, 6 males, 2 females. However, those shouldn't be included within the same column. Those should be split up because you really shouldn't include more than one piece of information in a cell. This will limit the way in which you can analyze your data. If you need both of those measurements to design your data sheets, include that information in there. And the simplest way is, yeah, just to create 2 columns, one for males and one for females, and then you can just put an integer in, and then you don't have things like a string. You're not mixing letters and numbers, and it's easier for you to analyze. The other thing you can keep in mind is column F, you have weather conditions, and they're very repetitive, and those can also be split up into their own columns if you are also using those for analyses, because that will save you some time in the future. Dates as data. Dates in spreadsheets are stored in a single column. I think that a lot of us have done this in the past. While this seems like the most natural way to record dates, it's actually not the best practice. A spreadsheet application will display the dates in a seemingly correct way to a human observer, but how it actually handles and stores the dates may be problematic. In particular, please remember that functions that are valid for a specific spreadsheet program, be it Microsoft Excel, OpenOffice, Google Sheets, are usually guaranteed to be compatible only within the same family of products. If you will later need to export that data and need to conserve the timestamps, you're better off handling them using one of the solutions that we will discuss. So in this example right here, this is within Excel spreadsheet. So what was typed in is the information that we have on the left-hand side, and converting it into each of these formats will yield, similar results. But then when you look at the number at the far right, why do you think there's a number there? Is anyone familiar with how Excel deals with dates? So Excel actually assigns each date into a numeric value. However, the caveat of that is that it will only translate post 1900 dates into the internal format. So if you're working with historic dates, you really want to think about how you're storing dates in your spreadsheet, because it will not know what to do with dates that occur before 1900. And so it will assign a number to some of the dates. Like right here, July 2nd is 44014. But then for January 1st, 1900, it's assigning that as 1. There's also issues of like, if you're typing something in like 3/4, like March 4th, Excel is thinking that that's actually a fraction and is assigning a different numerical value for that. So the best way to store your data when you're dealing with dates is to actually store them as separate columns, especially if you are switching between software, so that your year is one column, your month is one column, your day is one column. Of course, you may find that storing your date in one column works well for you, but it is something that you do want to keep in mind, especially if you are converting it between software or importing it into something else. Okay, so here we are back at the first example that we looked at before we started talking about common mistakes. So how do you think this data set can be improved? Feel free to write out in the chat just first things based on what we talked about. What can be improved? How can we transform this data set into something that is more usable and more reusable for others? Adjust the dates to be a similar format, exactly. It can all be one table, separate year, month, day into columns, yep. Combine it into a single data table, so yeah, create a similar headers with similar variable names to put it together. What about the gray area, the gray cells? Separate male and female columns, yep. Keep only one piece of data to each column. And any extra information that is not contained within the tables, create new columns for, so that you can put those into extra columns. Or also create a text file for description. So based on that information, we can potentially recreate that spreadsheet, that data set, into something that looks like this, where you have one piece of information for each column. Everything is compiled within one data set, and then you have an additional README file for additional pieces of information. So when you're working with spreadsheets during data cleanup or analysis, is easy to end up with a spreadsheet that looks very different from the one you started with. So just to refresh, this looks very different than what we end up with. When you're creating a new file with your clean or analyzed data, it is very important to have a starting point for comparison in a file to start over with if something goes wrong or something needs to be changed. So it is very important that even if you are starting off with something that looks like this, you are not making the changes within the same file. You are actually saving this as your raw data, and then you're creating a new file with your new changes. And if you are so inclined, keeping track of the steps you took in your cleanup or analysis. And this is important because tracking steps, like in an experiment, is important for others so that they can replicate your work and so that you can understand what decisions you made in the future. If you are planning on tracking changes, those should be kept in a plain text file stored in the same folder as your data file. I've been talking a lot about text files and plain text. Any thoughts about why you might want to use a plain text file instead of something like a Microsoft Doc? Plain text files can be opened anywhere. Yes, exactly. So because they're not proprietary, they don't belong to a certain company or certain piece of software, anyone can open them with a variety of different softwares. And it doesn't require updating the file to maintain access. And it is just very reusable. You can send it to anyone and they can always open it. Yep. So based on all of these things that we talked about, the best practices can be summed up to leave your raw data raw. If you're going to make any changes whether that's either changing the variables, converting them to prepare for analyses, or changing your structure because you would like to improve on it, make sure that you're keeping your original file and you're making changes in a different file. You want to put your variables into columns with one instance or one observation in its own row. You want to add other variables instead of formatting or commenting. You don't want to combine multiple pieces of information in one cell. You want to document information about your data in a text file or an additional piece of that's separate from your spreadsheet so that if you are sharing it or if you're running it through some sort of code, you don't have to deal with the fact that the computer is reading everything as one row. And the extra thing that I'm leaving you with is consider exporting your clean data or your final data set into a CSV format for the same reason that we create things in .txts, plain text files that are not proprietary. Changing things into CSVs, though, that is the equivalent of a non-proprietary spreadsheet file. That just ensures that anyone can open it with any sort of software, and you don't have to worry about, oh, I used Microsoft Excel in 2000, and now my spreadsheet is no longer compatible with the version of Excel that I have access to right now. This is a little beyond the scope of this lesson, but I want to highlight it because I think versioning is super important. While I'm on campus, I use OneDrive, and I keep all my files in there. Now, if you actually look at the properties of that, you don't see any previous versions. But if you log into gowu.edu and you go into the W Exchange and you click on your OneDrive folder, from there, you can access your files and look at the version history. And you're able to see what all the versions of your files are when they were modified, and you can either open those files or restore them if you've made some sort of mistake. In addition to that, OneDrive allows you to access your files anywhere, so you don't have to be using the same laptop that you saved it or were working on the file. So it's good to consider that, especially since this is an option on this campus for you to use. Okay, last part of this presentation, we're approaching the finish line. So we talked a bit about when you have, you're structuring your data set to have variables in the order that you want to enter things in, and you're thinking about how we're splitting up the information so it can be reusable. However, quality control is also very important. There are several techniques that you can use within your spreadsheet to ensure the data you enter is free of errors. These approaches include techniques that are implemented prior to entering the data, quality assurance, and techniques that are used after entering data to check for errors, quality control. So quality assurance using data validation within Excel. Quality assurance stops bad data from ever being entered by checking to see if the values are valid during data entry. For example, in this case, you have a researcher who's entering a piece of information within the column population type, and they entered city. However, because data validation was employed on this spreadsheet, it will show up an error that that they actually need to enter urban or rural. And the way that this was set up was going into data and then the data validation tab and putting in a list of values so that they will match exactly, and it will appear as a drop down in your spreadsheet. This prevents someone who is entering any sort of data from ever being able to enter anything else than what you would like to see in there. And then you don't have to worry about going in and, oh, did they actually enter the right thing, or are there any sort of variations within what they're entering? Quality assurance and data validation is something that is present within a lot of different types of spreadsheets, spreadsheet software. So in Google Sheets, you're also able to do the exact same thing. Within the data tab, you can go into data validation. And similarly, you get a pop-up window and you can choose what are your criteria so that you can go ahead and have a pop-up window when someone does not enter the correct information, and some helpful advice for when they are actually entering information. If you don't have either of those software, you can also do the same thing within OpenOffice. It is pretty standard across all of these different software to have this type of control. The other thing that I would encourage you to do is using sorting and scanning for quality control. So within sorting, bad values often sort to the bottom or top of your column. For example, if your data should be numeric, then alphabetical and null data will group at the ends of the sorted data. Sorting your data by each field, one at a time, and then scanning through each column, you are able, if you're looking at the top and bottoms of your column, you can see whether there's information that sticks out. For example, in this sorting exercise that you see displayed, you can see that someone had entered units within weight grams, and they put 22 grams, which is different than what the other entries are. This can be problematic because if you are then analyzing this data, the 22 grams will be treated as a string and not as a value. And so you can't easily make calculations. However, sorting also allows you to see that maybe there are some sort of outlier within your data. So if you see something that says like 400 grams and everything else is below that, that could also be an indicator that things were not entered correctly. If you are doing this and you are sorting your data, it is good to maybe sort your data in a new file. And it is important to remember to expand your sort area in order to prevent data corruption. So usually, I know Excel gives you a pop-up. If you haven't selected all your data and you're just sorting on one column, that will result in the one column being sorted and not aligned with the rest of the data that you're entering. So just be very careful that you're selecting everything before you're doing any sort of sorting. The other thing you can do is scanning. This is depicted by the two different colors, the green and the red. You can go ahead and color code maybe the top 10% and the bottom 10% of your data just to check for outliers. That's a good way to see if something might be beyond, something might have been entered incorrectly or an extra zero might have ended up within your data entry. And finally, I'm going to put this out there. It might not be super relevant based on what you're doing, but using double data entry is sometimes a very useful technique when trying to make sure your data is top-notch. The literature is mixed on the benefits of double data entry, but personally, I have found it to be a good way to identify errors from fatigue when entering responses from paper questionnaires. Because human data entry can result in errors that ruin statistical results and conclusions. So it is a good strategy if you have a lot of data that needs to be manually entered and you'd like to verify that the correct value is being entered and not just the correct data type. So remember when we did data validation, you have some sort of criteria that you can set, like either a list with variables, specific types of words you would like to see, or maybe you have integers within a certain range from like 0 to 100 that can be entered within a cell. However, that does not stop it from being the correct value. So someone can mistakenly enter an 8 instead of a 10, and that will fit within your data validation from 0 to 100, but it won't be the correct value. So doing double data entry, which is you have either two individuals or one individual entering the same data twice, and then doing a check will show you whether or not there is a discrepancy within the data being entered. However, it is a very time-consuming process because it does require two separate coders or someone doing the same data entry twice. It does take time. It also requires some minimal setup. The setup is not too bad. If you are thinking about giving this a try, you can just do an easy if formula. So if you set up your entry in one tab where you see coder number 1, and then you set up the second entry where you see coder number 2, and you keep the same structure, then you're easily able to go and compare the cells across those two tabs and see if there is a discrepancy. In this case, the if formula is saying if that one cell within the tab for coder 1 is exactly the same as the same cell within coder 2, then put a 0, in which case there is no discrepancy. But if it is false, if there is a discrepancy, put a 1. And then you can go ahead and use conditional formatting to find all the instances of 1 and see whether or not there was a discrepancy. So that's how you would go about doing that. The other thing you could do is you could set this up however you'd like. So you could put in a condition which maybe has blanks when there is no discrepancy, but if there is a discrepancy, you can put in both of the entries for coder 1 and coder 2 so that you can easily compare and see, oh, this coder accidentally pressed 8 twice, and so the first coder put 8 and the second one put 88. Let's go in to make sure that that data doesn't end up in my analyses. And that is it. So this workshop, it was a condensed version of the Data Carpentry workshop, Data Organization and Spreadsheet for Ecologists. It has a lot of great additional information and some practice exercises. So if you'd like to go ahead and practice some of the skills or explore some other exercises, feel free to use that link. I am also available for additional conversations if you have a project that you're working on that you're trying to set up, some questions about how to set up your spreadsheet or what's the best way to ensure that you're managing your data efficiently. I am happy to have those conversations with you. So I'm going to stop recording and open up for any questions.